Live. There you go. Now we're live. Okay, so let's take a look at this. Today's objective is talking about linear functions. Okay. All right. So what? What? Linear functions? What does that mean? Well, we know that functions are going to pass that vertical line test, right? Functions means that this part right here means every x has exactly one y. We talked about that yesterday. And linear means straight, okay? So we want the straight ones. Now there's going to be some in here that aren't going to be straight. We'll talk about that, okay? So what is a linear function? Well, it's a straight line. It's a straight line or graph because we're going to be graphing, okay? Nonlinear just means they're not straight. Nonlinear, they're just not going to be straight. They're going to be curvy. Curvy, okay? Okay, they're going to have curves like a parabola. A parabola is not, it's not linear, it's not straight. It's got its own name, right? It's got its own name called a parabola, okay? Now, solutions to a linear equation in two variables, okay, is any point that is on that line. Okay? Any point that's on that line. Example, real quickly. This point right here, this point 2, 12.6 is a solution because it's on that line, isn't it, right? And if I plugged in 2, I'd get that answer. It's a solution. Kind of makes sense to me. It's not that hard. Okay, now, let's take a look at this equation. Y equals x plus 3. That is going to be a graph. This is going to be a graph, but the thing is, every single graph has got its own name. You with me? Every single graph has got its own name. The graph we're going to graph, its name is x plus 3. Okay, what does x plus 3 look like? That's got a graph. It's got a name. What does this graph look like? Well, if you plug in -1, all right, so we're going to take all of these values and we're going to plug them in for x. Now, they did the work for us. I like that, huh? They did the work for us. We plug in -1. -1 plus 3 is 2. Yeah. They did the work for me. Plug in 0, 0 plus 3 is 3. Yeah. 1 plus 3 is 4. Yeah. And then 2 goes in, I get an answer of 5. Now, that turns out to be a graph. So let's take a look. So then way over here, we can create these and make these points. So these are really points like, well, -1, 2, a point 0, 3, a point 1, 4, and a point 2, 5, right? That's all that is points. So I plugged them in. I got y values. It makes a point. So let's check it out. -1, 2, yeah. 0, 3, yeah. 1, 4, yeah. 2, 5. Now this line right here has a name. The name of this line is y equals x plus 3. So every line has a name. The name is its equation. I'll say it again. Every line has a name. The name of the line is its equation. Thumbs up. And every different line has a different name, right? Okay, so let's look at some different lines, okay? So, discrete domain and continuous domain. We'll talk about that real quickly. They didn't give us a very good example. I'll give you an example of discrete, okay? We did this yesterday. Let me put a discrete one down, okay? Let me give you an example. They did not do a very good job of this. I'll give you some points, okay? Okay, here, 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 and here, okay? All right. How many points do you see? 4. Can you count how many points are here? I know that seems obvious. Of course you can. So the word discrete just means countable. How many points are here?
3.
4, right? So this is a discrete graph. You can count how many points. How many points are here?
4, 5, and 5.
Infinite. Why do you say infinite? You're right.
Because it's like all the points on the line.
It's all the points on the line, right? So check this out. I mean, if I look at this, every look, is there a point right here?
Yep.
Is there a point right here? Is there a point here? Is there a point right here?
Yes.
How many points are on this line?
Infinite.
I agree, infinite number of points. So this one is going to be what we call continuous, because it has a continuous line, right? Discrete. So continuous, if you can keep drawing and never have to pick up your pencil, it's continuous. Okay, let me bring it down, okay? We even teach this in calculus, because calculus has graphs that have holes in them.
What?
Yeah, I know, crazy,
Is
huh?
that even possible?
Yeah, it is possible, yeah. So anyway, we'll get there later, okay? So think about this. We talk about in calculus, we say if it's continuous, you can just keep drawing with your finger and never have to stop, okay? But if it's discontinuous or discrete, I gotta pick up my finger and go to the next one. Pretty easy, right? Continuous and discrete, okay? Yeah, and calculus has some weird graphs. You gotta pick up your finger, go to the next part. Has holes in them, but that's calculus, okay? Okay, so now, this is obviously discrete. You guys see it? This one is continuous because how many points do you see here? A lot, right? Infinite. There's a whole bunch, okay? Thumbs up on continuous and discrete. It's an easy topic, okay? Turn the page. We're doing okay? All right, now, number one. Is that, okay, here's the word. Is this linear
No.
or is it straight? Is it straight? No. It's curvy, so it's non-linear. That's a square root graph, actually. That happens to be a y equals a square root of x, but you don't need to know that until you get into geometry. For right now, it's just non-linear, okay? How about number two?
Yes.
It's linear, isn't it? Straight, so it is linear because it's straight. Isn't that easy? Okay, number three. Now, how do we know just by points? There's two ways to know. One is to graph it. That's the easiest way, okay? So number three, if I'm not sure, I can take my graph paper. I'm going to show you two ways. Because sometimes you're like, oh, Mr. Davies, I don't have a piece of graph paper handy. Is there another way to do it? Well, let me show you the hard way. If I go 1, -1, I go 2, 2, whoops, 2 2's here, my bad. That's not there. 2 2 3, 1 2 3 4 5, 4 8. Does that look like it's straight?
No.
Yes.
Oh, yeah.
Yeah, that does, doesn't it, right? Okay. Okay, how about number 4? Let's see 4. I'll do a better job of graphing because I did a lousy job of graphing that time, huh? -1 0, 0 -1, 1 0, and 2 3. Is this one going to be linear? No. Okay. Now, here's another way. Okay. Here's another way to do number 3. Goes up by how much? Up by how much? Up by how much? Up by how much?
1.
3. Up by how much? Up by how much?
3.
So if it goes up by the same amount each time, it will be linear. We're going to learn that later, okay? And if you can't, just graph it, right? Make some points. You say, well, it's a straight line. It's linear. If it's not, you know, we can always graph points and say, okay, it's not. Okay? All right, number 6. Let me rewrite this. Really a y equals a 3 minus 2x, okay? Now, you know, I taught you. How do you know if that's linear? How do I know it's linear? I know it's linear. It is linear. What's the invisible exponent? There's an invisible 1 right there. If it is to the power of 1, it's always linear, okay? Will you believe me? Always. Now, it's always an invisible 1, but it's x to the 1 power. So, yes, that is linear, okay? How about 6?
No.
What's the exponent?
3.
3. That's not. In fact, this graph looks something like this. It's going to look something like this. And you don't need to know this. It's something we'll learn in Algebra 2. Okay? All right? We'll learn that later. But you guys know it's not because it's got a power of 3. Okay? So it's non-linear. Okay? All right. Almost done. Is this one continuous or discrete?
Continuous.
It's continuous because I can draw straight down, never pick up all the points. So this one's definitely continuous. And what about number 6? Continuous or discrete?
Discrete.
Discrete, right? Because I got 3 points. This one's discrete. I always spell it wrong. Discrete. Good thing I have. Okay, what do you think? Easy day?
Yeah.
All right, I like it. Okay, so I do have a little bit